All right, let's dive straight into this explainer and look at exactly how we're going to power the incredibly high-tech world of 2030, without destroying our planet in the process. We are literally on the verge of this technological renaissance, but there's a massive elephant in the room here. All of this dazzling new tech requires just an unimaginable amount of electricity. And the answer to that? Well, it requires a radical clean energy revolution.
Think about it. By 2030, our civilization is going to be running on some truly mind-bending technologies. We're talking zettascale supercomputers doing a billion calculations per second, or mainstream artificial general intelligence basically acting as your creative partner. I mean, you might even have a digital clone sitting in on your boring virtual meetings while you're out at the beach. Add a quantum internet and universal translators to the mix, and you get the picture. But here's the catch. Every single one of these innovations requires absolutely astronomical amounts of energy to run. And it really is everywhere. Every facet of daily life is going to be constantly pulling massive amounts of power. In healthcare, we're talking about 3D printing human organs to totally eliminate transplant rejection. Over in defense, things like hypersonic missiles require AI to instantly analyze threats. And just in your daily life, you'll have foldable electronics wrapped right around your wrist. So, no matter the sector, it all points back to one inescapable reality: unprecedented nonstop energy demand. Which brings us to a really looming, absolutely critical question. With all of these amazing advancements, how on earth do we generate enough electricity without accelerating climate change? Because, let's be real, we simply cannot rely on the fossil fuels of the past if we actually want to survive to enjoy this future. Section 1. Enter the SMR revolution. The quiet engine behind 2030's flashy tech. Okay, meet the Small Modular Nuclear Reactor, or SMR for short. These things are the transportable, factory-built backbone of the whole 2030 energy grid. Instead of those hulking concrete monoliths you usually picture with nuclear power, these are compact, highly efficient units. They utilize advanced, carbon-free fission to provide 100% clean, zero-emission energy. Plus, they are incredibly low-risk, remarkably safe, and get this, they can run for decades on just a single fuel cycle. To really put that into perspective, contrast it with the massive fossil fuel and traditional nuclear plants of the past. Those took years of custom building and relied on these sprawling transmission grids that lost huge amounts of energy over long distances. But 2030 SMRs, they sit right where the power is actually needed. They're built in a factory, shipped directly to a site, and they basically plug directly into the local grid. It totally wipes out that transmission loss and massively boosts the resilience of our infrastructure. Section 2. From remote to urban, deploying power exactly where it is needed. Because they're modular, SMRs seamlessly adapt to pretty much any geography. In cold northern towns, they're stepping in to replace dirty diesel, safely heating entire communities through brutal winters. On tropical islands, they provide constant, clean electricity for homes and run these portable solar desalination systems to create fresh drinking water. In urban centers, they fit right into the city limits to support EV grids and data centers. Meanwhile, out in industrial zones, they're powering carbon-free factories and clean hydrogen production. There's a line from our source material that really hits the nail on the head here. Energy isn't just cleaner, it's smarter, steadier, and more accessible than ever before. It truly democratizes power. Whether you're living in a bustling metropolis or some remote coastal village, you have the reliable, clean electricity you need to thrive in the 2030 economy. Section 3. Smart grids distribute the power, the intelligent nervous system of 2030. But listen, generating that clean power is really only half the battle. Distributing it intelligently is where smart grids step in. Here is how this life cycle actually plays out. Step 1, an SMR generates stable carbon-free power right there locally. Step 2, the smart grid acts like an intelligent nervous system, routing any excess power over to community batteries or even directly to your neighbor if their solar panels happen to be in the shade. Step 3 is just incredible. Your electric vehicle actually becomes a mobile battery. It charges when power is cheap and then feeds electricity back into the grid during peak hours. And finally, step 4, if a massive storm hits, the grid automatically isolates neighborhoods into these resilient microgrids to prevent blackouts. So it completely flips the script. Electricity is no longer this passive, one-way street. It's an active, adaptive conversation.
Utilities are partnering with households to show real-time carbon footprints right on your phone. Families are actually gamifying conservation, earning rewards for helping balance the load. Everyday people are now active participants in their community's clean energy resilience. Section 4. Reversing the carbon footprint, using clean energy to heal the planet. Now here is where it gets incredibly cool. Once the immense power demands of our AI and our cities are met by SMRs, we can take that massive surplus of clean energy and use it for something vital: active carbon sequestration. We're talking giant direct air capture machines humming on the outskirts of cities, pulling CO2 straight from the sky. We're using coastal marine capture systems like underwater kelp farms to store carbon safely in sea rock. We are literally converting captured CO2 into carbon-negative bricks to build our homes. We finally stop just trying to survive and we start aggressively healing the environment. Think about how far we've come. In the past, our industrial eras were just choked with smog and unmanaged emissions. Today, we're doing better, deploying AI and drones to monitor natural forests and track carbon absorption. But the future? The future introduces artificial trees. Powered entirely by our clean SMR backbone, these sleek, high-tech towers stand in parks and along highways, and they silently filter pollution 24/7 to release clean oxygen. They ensure the next generation grows up knowing that clean air isn't a luxury, it's a fundamental right. Section 5. A clean energy future, the invisible hero of tomorrow. Okay, so let's tie this whole shebang together. Whether we're talking about curing diseases with custom 3D printed organs, preventing crime with ultra-fast AI networks, or connecting the entire globe via the quantum internet, none of it works without power. Every single dazzling innovation of 2030 fundamentally relies on one invisible hero: the localized, limitless, and 100% clean power of small modular nuclear reactors distributed intelligently by smart grids. We are entering an era where energy is no longer a bottleneck, it is literally a blank canvas. So I'm going to leave you with this to think about. With SMRs making clean, safe energy local and virtually limitless, what will your community build with its power?